Hello, Accelerated Math 7-8 students. We are continuing in Module 11, Lesson 6, and it is called Conditions for a Unique Triangle, looking at the three sides condition, and it's found on page 74 of my book, so we're going to turn there now. Conditions for a unique triangle, three sides and two sides and include an angle conditions. The goal for today we will learn the criteria that makes triangles unique. The question that I want you to think about during this lesson is, what is one thing that makes a triangle unique? We do have a things to know category, and it is rather long, so I'm going to uncover it so that you can see it. Things to know. Conditions for unique triangles. There are three things that I want you to pay very close attention to because these three things tell you that a triangle is unique. The first thing that you need to be aware of is the measurement of the angles. The second thing that you need to be aware of is the measurement of the side lengths. And the third thing that you need to be aware of is the relationship between those angles and the sides. The mathematical notation that you need to understand when you're trying to decide if triangles are unique or not are, when shapes are copied, there is a visual mark called prime notation applied to the shape. So if you are making a copy of one triangle and you're trying to make it a copy so it's unique to that triangle, you need to have special notation to do that. And so we're going to learn about this in class when we do some practice problems. But there are certain conditions that we have that make a triangle unique. So the first thing that I would like you to try is, there are two problems that I would like you to try and do. And it says, try it, draw an identical triangle. So the triangle that I want you to draw an identical triangle to is this triangle right here. So we're going to make a copy of a triangle ABC. And if you're looking at this and you're sitting there staring at it, what automatically does your brain focus on so that you can attempt to copy it? If you said that the side lengths are what you're looking at, the answer is correct. You are looking at the three sides. The three sides of this triangle make it unique because you cannot draw another triangle that has these exact same units of measure without it being exactly the same, and that's what makes it unique. Okay, so we're going to attempt to do that. We need to draw a triangle that is triangle ABC. Okay, triangle ABC, and we know, if you're looking at it, that segment AB has to be 3.5 centimeters. We know that segment BC has to be 2 centimeters, and we know that CA, segment CA, has to be 4 centimeters. That is the only given information that we're given about this triangle. So if we're going to try to recreate it so that it shows that it's a unique triangle only having these specific side lengths, then that's how we have to try to construct them. So if I take my paper, I need appropriate tools. And the appropriate tools that I'm going to use, because it doesn't say anything about angle measures, so we don't have to worry about that at all. We just have to worry about side lengths. And the side lengths cannot be different. But the thing that I want you to notice is there is a certain placement of the side lengths that makes the triangle successful. And so we're going to try it. So the first one, it says, first of all, it's centimeters, so let me flip my ruler over. We're going to start with 2 centimeters. So I'm replicating the triangle, so I'm going to start with BC, because for some reason this segment is always the easiest for me to start with. So there's 2 centimeters. Then it says that I am supposed to go up 3.5. So I find 3.5 on my ruler, which happens to be right there. Line that up and draw the line until I hit 0. So there's 3.5 right there. So this right here would be vector B. So that must make this vector A. And this must be, not vector, excuse me, vertex. Vertex B, vertex A, and vertex C. This is 2 centimeters. This is 3.5 centimeters, like you just saw. So when I connect A to C, it should be 4 centimeters if I drew it correctly. So let's check and see if that's correct. And if you will notice, dun da da da, we have 4 centimeters according to my ruler. So I connect those two vertexes, and this is 4 centimeters. So now we replicated the unique triangle ABC onto my paper right here. Now, we were talking about mathematical notation. Did we just now make a copy of the given triangle? The answer is yes. So since we made a copy, this triangle is not called ABC. This triangle is called A prime, B prime, C prime. So this triangle ABC is what we were given, and we were told to make triangle A prime, B prime, C prime, because this lets the mathematician know that when they're looking at the information that this is a copy of this. And these little tick marks, called prime notation, are telling us that's what the copy is. So when you see on an exam and you see one shape, and then you see the exact same shape it looks like, but it has these little tick marks next to it, the exact same one is a copy of it. So the little tick marks, called prime notation, represent that it's a copy. Okay? We'll be getting into that when we have to make scale drawings of things, and you'll notice that. Okay, the second thing that I wanted you to try is, if you go back to our title, we're working with 3 sides, and then we're also working with 2 sides and an included angle. So if we look at this, we were given 2 sides, okay? 2 sides and an included angle, 1 included angle. That means the angle fits on the inside, and it's given. So this included angle right here happens to be 60. This side happens to be 3 centimeters. So let's see what we can figure out with that. So again, we're looking at one that has 3 centimeters as the side, 60-degree angle, and then we will also notice what we find about those sides, because it's supposed to be 2 sides and an included angle. So if we know that one of them is 3 centimeters, let's draw it. So here we go. One is 3 centimeters. Okay. And then we're supposed to have a 60-degree angle that attaches to that. So I'm using my protractor, and we have to find 60 degrees. So 60 degrees happens to be, I'll try it this way today because I learned from a student was a lot easier to use as your guide. So remember, precision is a mathematical practice that we have to have when we're working with geometry specifically, right? So in order to be precise, the end point of this line segment has to be exactly there and there. Okay, and that measures at 60. Okay, so then I'm going to put a little mark there. Right. Okay, so there's my little mark. And then I'm going to come here. I'm going to connect these 2 lines, making a vertex. This was 3 centimeters. And remember what I told you about leaving your extra marks on there so that I know you're using your tool? This is the one that we were given, so this one cannot be changed. So this is 3 centimeters here. And now I just have to close that triangle with the given angle of 60. It should, if it's truly a triangle, this angle right here should measure at, 60 as well. Okay, see how much easier it is to put it under? Okay, harder when it's on top, but we'll go with it. And we know that this is 60. So now I wonder what these side lengths are. Let's measure them and see. I think you know, just some of you may know already what it is because you know a lot about triangles. This one's 3 centimeters. I'm wondering if you know what this triangle is called from that. I'm hoping you know what this triangle is called in math. That's also a 3 centimeter. Okay, and since these are both 60, what does this one have to be? You should know. All right, so I'm going to let you guys figure that out and tell me tomorrow when you get to class what that missing angle measure is and what kind of triangle it is, okay? So what we just did, if we were to label it, this one in your notes was not labeled, so it's really hard to put your prime notation since it's not labeled. But if we did label it, then we would have the prime notation on each of your vertices. But since we don't have any letters, we'll just put the prime notation on the triangle itself. So what we talked about today was the 3 sides triangle being unique, and then this one is a 2-side and an included angle. So this side and this side were given, and so was the included angle, and so that's what makes it a 2-side with an included angle on the inside. Okay, not all of them look like this, but when you practice it in class, you'll start to make some connections as to what that means with 2 sides and an included angle. So our goal for today, we will learn the criteria that makes triangles unique. I'm going to tell you ahead of time right now that there are about 5 or 6 different conditions that we're going to learn. This happens to be 2 of them. So the 2 that this one is the 3 sides condition and the 2 sides and an included angle condition. Okay? That's what we're learning about how to make triangles unique. The question, what is one thing that makes a triangle unique? You should be able to answer that question from just the practice that we just did. So that's all I have for you today, and I will see you all tomorrow.